Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so I do hope that all of you are still in good condition then. Okay, so as you see on the screen here now, we continue our discussion on lecture 2 of 2 with the topic of combination. Okay, so in the first part of this topic, permutation, where we choose the object from the numbers of the object given there, and arrangement are methods. So in this 7.2, if there are, let's say, n numbers of letters, and we're going to need to choose only a few of them, and arrangement does not matter. We call this not important. Okay, we don't mind to whether arranged or not. We consider that as a 1. Okay. So as you see in the screen here now, you may read by yourself. Consider 4 colors: red, blue, yellow, and green. So select 3 of them. So it can be red, green, and blue. Okay, it can be, okay, never mind, I'll just recall list down the list here. It can be red, green, and blue, or red, blue, green, blue, yellow, green, or blue, green, yellow, and list out many more. Okay, these are a few examples. So choosing them as a red, green, and blue is the same as choosing blue, red, green. Okay, so look at this one here now. I choose a red, green, and blue, and red, blue, green. Does it make any different from these two? No. Okay, we still in here for these 2 examples, we still in our hand. We get 3 colors of we call ball, which is red, green, and blue. Okay, so then this is combination where orders does not matter. For these 2, which comes first? Is still we are talking about 3 colors of a block. We got 3 colors here, which is red, green, and blue. Okay. So given 3 books A, B, and C, how many arrangement of 2 books can be formed from 3 books? With A, B, and C. Okay, B, A, and C. So you come up with B, A, and B, C, or C, A, B, and A. Okay, as you see screen here now. So then the arrangement A, B, and B, A. Okay, and we got AC with CA, and BC with C and B. So there are 6 different ways and order of arrangement. From 3 books, we choose and arrange 2 of them. So combination of any books, the number of combination of 2 out of 3 books is 3. Okay, look at this one here now. If we talk about arrangement, there are 6 of them. But if we talk about if arrangement does not matter, it's not important then. So we got AB and BA. So in this case, AB and BA, if we, okay, for this question here, arrangement is important. If the other way around, arrangement is not important, A and B not equal to BA. So we consider this as a 1. What about AC and CA? Another 1 selection. And also BC with CB. Okay. Combination of any books, the number of combination of 3 books is equal to 3. So arrangement is important. If arrangement is important, AB does not equal to BA. So the different oppositely, combination, arrangement is not important. AB and BA are the same combination. So number of combination of R object taken from n distinct object without regard to order of selection is denoted by this one here, NCR, which is what we call n factorial divided by n minus r factorial times r factorial. Okay, permutation is an ordered combination here. This one. Okay, NPR. Yeah. Okay, in how many ways could a quiz team of 4 be chosen from a group of 15 students? Okay, class, just imagine that I'm a teacher of the class, and as we call college organize a competition among the tutorial group, and every tutorial class or group need to send a participant a quiz team of 4 being chosen out of a group of 15 students. So in my class I have 15 students. So I need to select the best 4 for this quiz, for this competition. So then if I select the best 4 and I set up the application form to the organizer, meaning the arrangement is not important. As long as I send it 4 of them, the names to the organizer, is done. Okay, so in this case here, which is the numbers of ways equal to 15C4. Then it is 15 factorial divided by 15 minus 4 factorial times 4 factorial. Okay, so 15 minus, okay, sorry. Okay, 15 minus 4 equal to 15 minus 4 is 11 factorial and 4 factorial. So 15 times 14 times 13 times 12 times 11 factorial. Okay, so 11 factorial divided by 11 factorial, and this 4 factorial is 4 times 3 times 2 times 1. Okay, actually that you can strictly get the answers from calculator. I counted to show you that we call how we count it manually. Okay, so then this one come up with the result of 1365. Okay, the numbers of ways of selection of team of 4 out of 15 students. A team of 7 players is to be chosen from a group of 12 players. One of the 7 is then to be elected a captain, another one is to be a vice captain. In how many ways it can be done? Okay. So class, just imagine there are 12 players. And from 12, I need to choose the best 7. Okay. The best 7 out of 12. So it is 12C7. Okay, let's say from the 12 now, recall I have already, then I have recall the list numbers of 7 best players out of 12, the last 7 players here. One of them will be elected as a captain and another one is a vice captain. So there's only one captain and one vice captain. So from 12 we choose 7. Then multiply with, from 7 we choose 1 to be elected as a captain, and from 6. From 7 we choose 1. So then out of 6, okay, the 7 minus 1 equal to 6. From 6 left we choose 1 as a vice captain. Okay, you get what I mean? First we have got 12 players, then we choose the best 7. And from the 7 we choose 1 appointed as a captain. Then the rest of 6, then here after 7 1 will be chosen, the rest 6 we choose 1 to be the vice captains. So this one come out with 332 64 ways of selecting this team. Okay, 5 students were chosen from a group of 8 boys and 5 girls. 8 boys and 5 girls. So the total number of these is 13 students. Okay. In how many ways could this group be chosen if there are to be more boys than girls in the group? 5 students were chosen from 8 and 5 girls. In how many ways could the group be chosen if there are to be more boys than the girls in the group? So the number of boys is greater than the girl of 5. So for this question, okay, total of 5 and the number of boys is greater than the girls. Okay, the first is 5 older boys, because the key here, boys is greater than girls, which is 5 greater than 0. So we're talking about numbers here. Okay, boys is greater than girls, or for all the boys, 5 and 0, 4 and 1, 3 and 2. So we cannot continue with the numbers of 2 and 3 because 2 is less than 3 and does not satisfy this with these rules here. So this is not one of it. Okay. Okay, so now from here, okay, the first one from, because okay, earlier we know that we mentioned in the question that there are 8 boys and 5 girls. So from 8 C5, from 8 boys we choose 5 and then multiply with 5C0. Okay, so use the calculator, find out the answers of this. It gives you 56. And then next, from 8 boys we choose 4, and then from 5 we choose 1, and this gives you 350 ways of selecting the persons. Okay, and then here 8C3 times 5C2 equal to 560. So the total of combinations here is 966. So combination means that if I choose 4 boys and 1 girl, do we need to arrange who will be the first, second, third, fourth, and fifth? No. Okay, it's not a matter. It's not important that. As long as we choose the 4 boys and 1 girl, then we send them to the competition or any event. Okay. That's it. Example 4. A committee consisting of 3 members is to be formed from a group of 25, including 5 women. How many different committees can be chosen without any restriction? What's the meaning of this? From a group of 25, including 5 women. Okay. From a group of 25, including 5 women, meaning there are 20 men and 5 women. So the total is 25. Okay, so out of these 25, we choose 3 members, okay, to be formed from a group of this without any restriction. Okay, so for this one here now, 3 persons to be chosen from 25. Okay, which is, for this one here without restriction, which is 25 C3. For first question here, 3 persons be chosen from 25. It's not a matter of how many men and how many women, as long as we choose 3 out of 25 persons then. So it is equal to 2,300. Then next, from 20 men and 5 women, So it can be 2 and 1, 1 and 1, 2, 1 and 2, and 0 with 3. Okay, for question B, I read the question again. So question B, if there is, must be at least a woman. So meaning that the members of 3 is combined. We call it member of 3. It must be have 1 woman at least. So if we send all 3 guys or 3 men, then our participant will be rejected. Okay. So now 2 and 1, 2 men, 1 woman, 1 woman, 1 man, 2 women, or no man at all, and then 3 women. For this case, come out with 20C2 times 5C1. And here, 20C1 times 5C2. And this one, 20C0 times 5C3, and give you 950, 210. Okay, so you may use a calculator to get all these answers. Each of these we call solution here. Every single thing here. So for this one, it gives you 950, 210. So the total is 1160. Okay. Okay, now the tips. Very often students, or not just the students, sometimes the teachers also sometimes confused. Okay, with the concept of permutation and combination, feel it to be confusing. So when are we going to use when the question that is a permutation, and when is the time that we need use the combination? Some tips to be memorized. Permutation, position is important, and combination we choose only. So position or arrangement is not important. Given the word of January, find numbers of way of arrangement 3 letters from the word of January, and find numbers of way to select letters from the word of January. Ways to arrange. So if we choose 3 of them, and then the number of arrangement is different and important. For this one, select 3 letters, and arrangement is not important. Okay, so for this one here now, for question A, from the word of January, okay, arrangement with 2 letters of A. Okay, so there are 1, 2, 3, 4, 5, 6, 7. So the numbers of letters equal to 7. From this 7, we arrange 3 letters. 1, 2, 3. Okay, so since that there are 1 letters A, that appears twice. A appears twice, 1 and 2. So the selection of 3 letters to be arranged here, it can be both of A. Okay, it can be both A in the selection, or might be only 1 A, or might be there's no A at all, so they are free. Okay, so then for this one here, arrangement with 2 A's. Okay, with 2 A's here, so it is equal to 2C2. From 2 A's, then we choose both of this, and then multiply with, if both of A's here, so how many letters left? 1, 2, 3, 4, 5. So 5C1, and then we arranged it, then it is 3 factorial divided by 2 factorial. It equal to 15. And if the situation here, arrangement with different letters, so then it is equal to, let's say 1 of A is not in the list, there's only 1, so 3 letters here, okay, there's only 1, it's not in the list, so we got 1, 2, 3, 4, 5, 6, so then it is 6C, 3 times width, because we, in this question of A, arrangement is important, so we choose the 3 and then we arrange it 3 factorial. It is equal to 120. So case number 1 plus with case number 2, so then 15 plus 120 equal to 135 ways of arrangement. 3 letters from the word of January. Then question B. Question B, find numbers of ways to select 3 letters from the word of January. So January, again, the N equal to 7. Then question B, selection with 2 letters of A and different letters, arrangement is not important. So then, case number 1, situation number 1 here, selection of 2 A's, okay, which is 5C1. Why did you say 5C1 that here? So class, why did we straightly come up with 5C1? Okay, so there are 3 letters that we're going to choose from the word of January. So there are 7 of them. 1, 2, 3, 4, 5, 6, 7. So 2 A's are already here. So if 2 A's is already in the recall the 3 what they're going to select that, so there are only 1 place left from 5 letters of J and U R Y. So 5C1. So then it is equal to 5. If selection with different letters, okay, so it is from 3, we choose 3 out of these 7. Okay, but then both of A's are not in the list of these 3. Might be 1 or might be not even single A. Okay, so we assume that there are 6 of them. So 6C3. And arrangement is not important because we only need to choose the 3 out of 6. So that this one come out with 20. So the numbers of selection here, 5 plus 20 equal to 25. Okay. To be numbers of ways select from the 3rd word of January. Oh, this is question of B. In mathematics examination, students will be given 8 questions. Students have to answer only 5. So how many ways the student may choose their question without any restriction? Then next, question number 2 and 4 are compulsory. It must. If question 5 is chosen, then question 6 should be ignored. Okay, so 8 questions, student have to answer only 5. Okay, from 8 questions, then student need only to answer 5 of them. So for question A, it is 8C5 equal to 56 without any restriction. Question number A. Question B, if question 2 and 4 are compulsory, so question number 1, question number 1, question 2, 3, 4, 5, 6, 7, and 8. question 2 and 4 is compulsory, it's a must. From 8 questions, we're going to choose 5 questions for this examination. For question B, 2 and 4 is a must. So, from 1, there's only one question 2, and we need to choose question 2 as a must. There's only one question 4 here, and it's a must. So, 1C1. So, how many is left here? 1, 2, 3, 4, 5, 6. Then, 6C. From question, there's only one question of 2 here. One question of 2 here, and it's a must. So, we choose the question 2. 1 from 1. There's only question number 4 here. So we choose 4. From 1, we choose 1. So the rest of 6, we choose 3. 1 plus 1 equal to 2 plus 3 equal to 5. So it's a 1 times 1 times 20 equal to 20. Okay. For question C, if question 5 is chosen, then question 6 cannot be chosen or be ignored. So there are only one question of 5. Okay, question number 1, 2, 3, 4, 5, 6, 7, and 8. So there are 2 situations here if question number 5 is chosen. Okay. So, if question 5 is chosen, automatically question 6 cannot be chosen, cannot be selected. So, there are 1C1. 1C1 represent, okay, if 5 question, there's only one question 5 here, so 1C1, automatically question 6 cannot be selected. So, how many is left then? 1, 2, 3, 4, 5, and 6. We wanted 5, right? 5 questions. So then 6C4. Then this is equal to 15. If question 5 is not chosen, it's not one of the questions that we selected, also chosen then. So then, okay. So from here, question 5 is not chosen. Let's say this is question 5 being selected. Okay, question 5 is not being selected means that we hide or ignore it. So there are only there are only 7 questions left. 1, 2, 3, 4, 5, 6, 7. Okay, so then is from 7 left, we choose 5 equal to 21. So, the numbers of ways equal to 15 plus 21 equal to 36. Okay, so that's all for today. And I hope that this lecture for part 1 and part 2 of chapter 7 helps you to continue your tutorial and pass your questions. And that's all. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.